Okay, let's take a look at problem solving with combinations. We've been looking at choosing a certain number of items from a group of items, choosing R items from a group of N items. But what happens if the number of chosen could be any size? You're kind of unlimited. You could take one, or choose two, or choose three, or whatever. So let's take a look at an example. Say we were considering 5 items, so that would be N equals 5. And we're going to either choose one of those, or 2 of those, 3, 4, or 5 of those 5 items. Well, that would simply be 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, and 5 choose 5. And of course, the total of each is given as 5, 10, 10, 5, and 1, which is equal to 31. Now, that seems like a lot of work. There must be a better way of doing this. And there is. If you think of the Pascal's triangle, we'll just go back to that for a second. Let's do a quick sketch. And you can see that those patterns are starting to emerge, right? 5, 10, 10, 5, 1, 5, 10, 10, 5, 1. The last row, not the last row, but the actual nth row, if you can remember that n equals 0, right? That's your top row. N equals 1, n equals 2, n equals 3, n equals 4, n equals 5. And you remember when we first introduced Pascal's triangle, we realized that the total at the bottom of each nth row can be given by, or sum, 2 to the n. Now, if you add these up here in the 5th row, with the n equals 5 row at least, that would be equal to 32. So the total is 32. Our total here is 31. So if we take a little closer look at this, really this is the total at the bottom of, or the nth row of the Pascal triangle, minus 1. So there's a formula that we can use. If we don't know that the total for that nth row is 2 to the n, and the difference is 1, well, then the general formula we can write for this is just given by 2 to the n minus 1. The total number of combinations combining at least one item chosen from n distinct items is equivalent to this. Let's take a look at an example. How many ways can a committee with at least one member be elected from 6 people? Well, again, our formula is 2n, 2 to the n minus 1. N equals 6. Because it says, of course, at least one member, so that could be 1, 2, 3, 4, 5, or 6, or 5, or 6. Therefore, 2 to the 6 minus 1, which is 64 minus 1, 63. Let's take a look at some a little more difficult ones. Combinations with identical or alike items. So here's the example. Jane's dog is spoiled. The dog has 3 stuffed toys, 4 ropes, and 2 Kongs. Those are the chewable things. How many different combinations of toys can the dog play with? Assume the dog will choose at least one toy. Right, so the null set, or having no toys to play with, is really not an option. So if we think about this in a different way, you can either have 3, 2, 1, or 0 stuffed toys. Which is really gives you 1, 2, 3, 4 options, really, when you're dealing with toys. You can have 4, 3, 2, 1, or 0. Ropes. Again, that's 5. So like there's 5 possibilities of having a certain number of stuffed toys, 0, 1, 2, 3, 4. Times there's 5 combinations of having either 1, 2, 3, 4 or 0 ropes to play with. And for the Kongs, 2, 1, or 0 Kongs. You don't have to have those as long as you've got at least one of the other ones. And that's 3. And if you notice, we multiply those because this is this and this and this. Now that is equal to 60. However, the 0 set, the null set, or having 0 of all, really shouldn't count because it says you've got to have at least one toy to play with. So we have to take that out, subtract 1. Therefore, there are 59 combinations. And as you can imagine, there's a general equation that we'll use for this. So in general, if choosing at least one item from groups of like items where you have P of one kind, Q of another, R of another, etc., you may choose all or some or none of the items from each group. But again, you want to have at least one item, so the null set or 0 of all has to be discounted. So therefore, by the fundamental counting principle, the total number of selections can be given as this. Number of P of one kind plus the 0 option, which is plus 1, times Q plus 1 times R plus 1. You can imagine you can continue that. It's depending on the number of items that you have. And of course then subtract that one option where you have none of all or none of each, which of course would disagree with this statement right here. So there's our general equation, how you'd handle those type of combination problems. Let's take a look at an example. So we have 5 rock songs, 2 blues tunes, and 3 jazz pieces. So it looks like we've got 10 songs in total. How many ways can you choose 3 pieces, including some jazz? So let's take a look. So let's think of it as, what happens if we have, say, there's 3 jazz pieces, so I guess we can have 1, 2, or 3. So we have 1 jazz piece, 2 jazz pieces, and 3 jazz pieces are our possibilities. And of course, maybe we start with the easy one first. Choose 3 pieces, including some jazz. Well, if all those 3 are jazz, then you basically have only one combination, all 3 of them. We show that by simply 3 choose 3 times 7. Obviously choose 0. This is just 1. Now backing up, let's go back to 1 jazz. Now, we have 1 jazz. We're basically choosing that one jazz song, and we're multiplying it by the number of combinations that we have left, which is really, when you think about the songs that we have left, we have 2 blues tunes and 5 rock songs, which is a total of 7, and we're choosing 2 more from that list. And that equals 63. If we choose 2 jazz songs, then it's something like 3, choose 2, and of course there's only 1 left to choose from that 7 songs of rock and blues, which is 21. So therefore the total, because each one of these is a different case, is 63 plus 21 plus 1, which is 85 ways. Now, there's another way you could do it. You can think of it using the indirect method. So if we think of all the combinations, right, minus the combinations with no jazz. Well, all combinations of songs, well, we've got 10 songs, and you're basically choosing 3. Minus the combinations of no jazz. Well, that would be like saying, well, the 7 songs, we've got rock songs and 2 rock and blues songs, so that's 7. So you're basically choosing 3 songs from those 7, the 5 rock songs and 2 blues songs, or tunes, times 3, choose 0. That equals 120 minus 35, which is equal to 85, which is the same as above. You probably didn't even need to show this. Okay, video's done.